Welcome back to another wonderful video about physics. I've written a few questions down here and you should have seen them on my website right above the video. These 5 questions are important. Number 1, what is the formula for circular motion? Number 2, which way does circular motion point? The force, that is. Number 3, why is centrifugal force considered the F word in Mrs. Giegler's class? Yes, we don't ever speak of it. Number 4 is simply a problem. And number 5 is, what would the free body diagram for the cup? What did we calculate the normal force to be? We will run through number 5 and number 4 in the second video. But for now, take note of the first 3. We're going to be discussing those, and it'll be really helpful for you tomorrow if you have written these answers down. Hint, hint, wink, wink, I would know the answers. Okay, so let's talk about the lab in this first question. In the lab, you found the relationship between different things. If you were going through and doing everything perfectly, sorry, let me just grab a thicker pen, you should have found that force was related to 1 over t squared, that mass was related to t squared, and that radius was related to t squared. If you put all of that together, you would have come to the equation of force is related to mr all over t squared. Now, I know not everyone got that exact relationship, and that's okay. That's just faulty data, and we'll talk about that as we go through the lab quiz. However, this is what we should have found. Now, this relationship sign that we see right there simply means that that's how these variables relate to each other, but there could be other constants that we're not dealing with. Therefore, our real equation for centripetal force is F centripetal is going to be equal to 4 pi squared times mr all over t squared, where F is our centripetal force. And when I say this is our centripetal force, I mean that's the net force acting on an object that's moving in a circular motion. We have m here, and that's going to be mass. Now, I know in the lab we measured that in in number of balls that we had. However, here in the equation and then throughout the rest of physics, we'll measure it in kilograms. R is simply going to be the radius of the motion that the object is going in. That would be measured in meters. And T is period. And as we discussed prior to the lab, period is the time for 1 revolution, or once around the circle. That will be measured in seconds. Okay, so this is our first main equation. Now, when we talk about these things, like I said, we're not introducing a new force. Overall, we know there's centripetal force acting on an object if it's moving in the circle. So if we take a bird's eye view of our lab, we would have had the little ball moving in a circle, and that ball was attached to a string that you were holding onto. Okay? Now, if the ball were left to its own devices, it would want to constantly continue in the same direction. So at all these different points, I'm going to label which way the ball was actually moving. Now, at this point here, at point A, it didn't continue to keep moving straight and fall out over here because the string held it in. In fact, the string pulled it towards the center of the circle. I lied at the very beginning. This is actually going to turn into 3 mini videos. This first one is simply going to have our major equation and the starting idea of the fact that the string was creating our centripetal force. So our centripetal force for our lab would simply have equaled the tension in the string. Like I said, centripetal force is not a new force, just a new net force.